So here's another video explaining for my students how to calculate a resistor value for an LED circuit. So let's draw a battery, and we'll have a resistor. The resistor is going to limit the current that flows around the circuit. These components are in series, so the same current is going through. Remember, current is just a rate at which the charge flows. So that's an LED, that's a resistor, that's a battery. We can give the battery any value. This time let's say 9 volts, and we don't know the resistor value. We do know just the voltage. Now voltage is potential difference. Voltage is the same as potential difference, which just means the difference from one side to the other. So if I say that this side is 0 volts, this side must be 9 volts more, because that is the potential difference between them. If that's 9 volts, we assume in an ideal conductor there's no resistance in this wire, so it's still going to be 9 volts here, and down here it's going to be 0 volts. So the question is, what is it there? Well, if this is a red LED has a typical voltage drop, a forward voltage drop it's called, which is expressed as VF, the forward voltage drop of about 2 volts. It won't be exactly 2 volts, but it's good enough for us. And then also it has it for typical brightness, it's going to have a current requirement of about 10 milliamps. Now that's just a generalization. Some are going to be more, some are going to be less, but for us that's fine. So remember, the same current goes around the circuit, so exactly the same current, 10 milliamps, is going to go through this resistor, through the LED, and the battery is going to supply it as well. Same current. Now if I were to put a voltmeter here, and remember the voltmeter measures potential difference, the difference between 0 volts and up here. I've already told you it's 2 volts, so the voltmeter will tell you that is 2 volts, which means therefore that we now know that is 2 volts. We know that's 0 volts, we know that's 2 volts, that's 9 volts. Now remember, voltage is potential difference, so if I put a voltmeter there, what is the difference between 2 and 9? It might be obvious to some, but not to all. So 0 volts, 2 volts, and then going along the scale on the number line, 9 volts. What's the difference between 2 and 9? Well, 9 minus 2 is 7 volts here. 7 volts the difference, so that is 7 volts. So now we know the voltage drop across the resistor, and we know the current. Remember, it's going to be the same current. Let's just add that in. The same current goes all the way around, 10 milliamps going through. Sorry, the pen's so thick. And so yep, we know the current goes through the resistor, we know the voltage across the resistor. So if we know Ohm's law, V I R, I've said it to you before, I like to draw it like this, helps people remember it. Let's just see if I can get this to zoom in a little bit, make it look a little bit like a chicken. I think that looks a little bit beak-like there, so make that a happy chicken. There we go. Okay, so we've got our little happy chicken there. We know the voltage drop, we know we don't know the resistance, we know the current that goes through it, so we want to know the resistance. So if we just cover over R, then we know that R equals V over I. So R equals V over I. The voltage difference, the potential difference was 7. The current is 10 milliamps. Now 10 milliamps is 10 thousandths of an amp, so that's 0.01, and that's going to be 700 ohms. Sorry, I didn't realise that was not on the screen. I don't think it was on the screen anyway. So 700 ohms. So resistance is volts over current. 7 volts divided by 0.01 equals 700 ohms. Now, likelihood is we're not going to have a 700 ohm resistor, so we can choose a nearest value. Now, in truth, it doesn't matter particularly how close you are. Anything within the range of even say something like 390 ohms would be still providing too much or more than 10 milliamps of current, but well within the ability of the LED, because most LEDs will be okay between about 10 milliamps and say 25 milliamps. So even if you halve the resistance, therefore double the current, it would still be okay. But I would probably in this particular case maybe suggest something like about a 680 ohm resistor, because we have one and it's not that different from the 700, and because we've gone down slightly lower in resistance we'll have slightly more current, but that's not a problem, because if we go for slightly more than 10 milliamps, no problem at all. Anything, as I say, between about 10 to 20 milliamps will be absolutely fine for the LEDs that we use. Hopefully that's useful. I'm probably going to make several videos covering the same topic, and then if you're still a bit stuck, have a look at the other videos that I'm going to post, and then hopefully you get it. If you have a bit of a problem with the maths as well, I'll show another way to do that too. Okay, so that's the end of this video.